My name is John Rushing. I'm Professor Emeritus at North Carolina State University. I've spent most of my life dealing with issues of food technology. I'd like to spend the time today to talk to you a little bit about revisiting your hazard analysis. We can take questions offline. The way we'll set this up, since there are a lot of people who can be on this line at once, you'll need to take a look at your panel, and there's a little drop-down menu for questions. If you'll type those questions in, we'll handle them at the end. I'm going to do my best to stay on schedule and deal with things in real time. I'd like to start by thanking PJR FSI, the Perry Johnson Registrars, Food Safety Incorporated, for inviting me to give this presentation. For those of you who have some familiarity with me and my teaching in the past on HACCP, you'll probably know that a lot of people call me Mr. Hazard Analysis because I have this burning idea that HACCP or any other food safety program cannot work properly without a good hazard analysis. Some of you may be asking where you can get a copy of my slides or a copy of this program. You can go to the Perry Johnson Registrars website, and I apologize for the clock in the back of the room. It will stop in just a minute. I'm sorry. You can go to the Perry Johnson's website and get this information. It should be on the website within 24 to 48 hours. That will include the recording and my slides. I'm trying right now to figure out exactly how to change my slides. I thought that I had that down pat. There we go. Okay, now principle number one of HACCP, as you know from past experience, is to conduct the hazard analysis. That has always meant to us that we have to enter a process of collecting and evaluating information on hazards and the conditions leading to their presence in order that we can decide which are significant for food safety and should be addressed in the HACCP plan. So conducting a hazard analysis has always meant to identify potential hazards and to design control measures, or in modern parlance in the United States, preventive controls to control those significant food safety hazards. We'll talk a little bit later about what a hazard that's significant for food safety will be. But generally, the hazard analysis is to identify the controls and then make an evaluation. Identify the hazards and then make an evaluation as to whether or not those hazards need to be controlled in our hazard analysis. And the hazard analysis Codex Alimentarius actually gives us some steps to deal with this thing. They say that we need to list all the potential hazards associated with each step. That's any hazard that our HACCP team or our team has decided to consider, and then conduct a hazard analysis by deciding if the hazard is significant, if it's something that is likely to occur, and then consider any measures that can be used to control those identified hazards. Now, we choose from the different measures available and decide if they'll be controlled at this particular step. You must conduct a hazard analysis in the United States under the Preventive Controls Regulation to identify and evaluate known or reasonably foreseeable hazards. Now, we'll talk about known or reasonably foreseeable hazards a little bit later, but you must conduct a hazard analysis to identify and evaluate known and reasonably foreseeable hazards for each type of food that's manufactured, processed, or held at your facility, and determine whether or not there are any hazards that do require a preventive control. And we do that based on experience, illness data, scientific reports, and other information. Now, in this situation, experience may not mean your own personal experience. It may mean the experience of experts and references that you can lay your hands on. Obviously, anytime there is an illness that's associated with a product very similar to ours, we'll try again to evaluate our hazard analysis to make sure that we're covered. Any scientific reports, any dear colleague letters from FDA, any new information needs to be evaluated. And just for your information in this particular guidance, the term "you" means the owner, the operator, or the agent in charge. Now that means that that person is to have a hazard analysis conducted, but actually it's the preventive controls qualified individual that has to be leading the team that conducts that hazard analysis. In addition, the hazard analysis must be written regardless of the outcome of the process. Now this is important because later on we're going to have to revisit the hazard analysis and reevaluate the hazard analysis and validate the hazard analysis. To be able to do that, we have to have written background, and that's going to become very important to us. Written hazard analysis can take a lot of forms, and we'll talk about those forms here in a minute. Now, I told you we'd revisit the term known or reasonably foreseeable hazards. Now, there are a lot of things that could fall under the concept of known or reasonably foreseeable hazards, but generally they include biological hazards, including microbiological hazards such as parasites, environmental pathogens, and other pathogens. A lot of different things can be taken a look at under the concept of biological hazards. What we're interested in are those things that are going to cause illness or injury in a consumer. There's also the concept of chemical hazards. And for the first time in the preventive controls regulation, that includes radiological hazards as something that's called to our attention. Normally, chemical hazards, radiological hazards, that's all dumped into one category. But now, it seems like we're going to have to take a look at these a little bit better. Now, who's going to take a look at radiological hazards? Probably not me in my particular situation. Many of you will not. But there will be some people that will have to take a look at radiological hazards. For instance, are there any radiological hazards associated with seafood that is coming into your facility? So just remember that radiological hazards always have to be in the back of your mind. And if you're in one of those industries where radiological hazards could factor into the process, then you're going to have to deal with that. Normally, we think of chemical hazards as substances such as pesticides and drug residues. Anytime you talk to people about food safety, it seems they're always interested in pesticides and drug residues. We also have to consider natural toxins, the effects of decomposition of particular components of the food, or unapproved food or color additives that might migrate into the food or might be added to the food. And then there's the whole concept of food allergens. Finally, we have a regulation that puts a lot of emphasis on food allergens. And there is a requirement that we have to identify those things that are necessary to control food allergens in our hazard analysis. We also have to consider physical hazard. What's a physical hazard? Now, physical hazard, this slide says things such as stone, glass, metal fragments. It's generally something that's going to break a tooth, choke you, cut you, something of that sort, cause that kind of injury. So those are the known or reasonably foreseeable hazards that we need to include in our hazard analysis. We may or may not need to consider all of them, but they should be in the forefront of our mind. So the question of hazards, remember we're defining hazards as something that's likely to cause illness or injury in a consumer. The hazard may occur naturally. For instance, it may be, well, if you've worked in Africa, it may have to do with the toxin that's naturally formed in cassava that has to be leached out before cassava can be utilized. It may be a hazard that's unintentionally introduced. It may be something that comes from milking a cow that has accidentally got into the wrong part of the milking strain, and we have commingled that antibiotic or therapeutic drug that cow's been treated with the rest of the milk. Or it may be a hazard that's intentionally introduced for purposes of economic gain. All of us are familiar with the problems that we had with the melamine in China and some of the follow-up types of economic hazards that had been introduced. But take a look at what occurs naturally, what may unintentionally be introduced by migration or some other system, and those that might be intentionally introduced too. Those are all known and reasonably foreseeable hazards. After we have after we have identified potential hazards, then we must have an evaluation of those hazards. The hazard analysis must include an evaluation of the hazards that assess the severity of the illness or the injury if the hazard were to occur, and the probability that the hazard will occur in the absence of preventative control. Now, when you take a look at this, I think you need to note the concept of severity of the illness. This has been a debate over the years in hazard evaluation, is how severe a hazard is a hazard. Well, I think that we got some really good information when we had the juice HACCP regulation, and they just defined a hazard as something that can cause illness or injury in a consumer. If it can cause illness or injury in a consumer, then it's severe enough that we're going to have to deal with it. Also note that the hazard evaluation has to include an evaluation of environmental pathogens. For instance, the pathogens that occur on the equipment itself or even in the air handling system. Let's say you're talking about a poultry slaughter operation and the air handling system moves the air from one direction or another. Well, if it moves from an area that has been passing across the slaughtering operation and going into a ready-to-eat operation, obviously it's going to be a concern, and we need to deal with that, with those hazards. So generally, if you have a ready-to-eat food, it's exposed to the environment prior to packaging, and the packaged food doesn't receive a treatment, or otherwise include some sort of control measure that would significantly minimize the hazard, then you have to have a control in place. I want to go back. Let's just take a look back here. This note here, the last sentence there, that would significantly minimize the hazard or the pathogen. What is significantly minimize? I'm going to leave that concept for a little bit later because I want to deal with the whole concept of what a hazard is. Remember, according to the regulation, a hazard is defined as any biological, chemical, and that's including radiological, or physical agent that has the potential to cause illness or injury. So if it can cause illness or injury in a consumer, it's important enough that we can deal with it, or that we have to deal with it. And so that means that it is a significant hazard. So the question is, does this really square away with this part of the definition? It must include an evaluation of the hazards to assess the severity of the illness or the injury if the hazard were to occur. Well, obviously, you're going to pay real close attention to hazards such as botulism, the growth of botulism and production of toxin, because, well, the symptom of botulism is often death. But the question that you have to ask is, if a hazard is likely to cause illness or injury in the consumer, doesn't it have to have control anyway? The probability that the hazard is likely to occur in the absence of preventive controls in HACCP parlance or preventive control parlance is referred to as the likelihood of occurrence. Since we've already defined a hazard as a condition that has a potential to cause illness or injury, that's a typo on the slide, if it has a potential to cause illness or injury, it's determined to be likely to occur, and we must provide a preventive control. If we have determined that likelihood of occurrence, we don't have to worry too much about the significance of the hazard to determine whether or not we have to control it. Now, there are a lot of things that go into a hazard analysis, and Codex Alimentarius has given us some preliminary steps that inform our hazard analysis and actually give it some structure. They call these the preliminary steps to hazard, or we've always called them preliminary steps to hazard. They actually just call them the first 4 or 5 steps to hazard. The first one, obviously, is to form a HACCP team, to get hold of a group of people that are qualified to make these hazard determinations, and describe the product, including the ingredients, and the ingredients' potential degradation or toxic effects and the conditions of use. Product description can include a lot of things. I think when I think of a product description, I'm mostly interested in what's going to happen to the product itself. You know, how are we going to process it? Is something going to change in the process? Is there something that is going to degrade and produce something that has a toxic effect? Are there toxic effects associated with the use of the product? And what are the conditions of the use of the product? The next concern after the product description is we need to be able to identify sensitive populations and how the product is to be prepared and consumed. Now, probably in your classes in the past where you've dealt with hazard analysis, you've probably dealt with a lot of different concepts of sensitive populations like pregnant women for Listeria monocytogenes, geriatric feeding, infants, dealing with special populations that are unlikely to be able to deal with a particular hazard. Those populations should be identified. However, most of the food industry has to deal with the population in general. One of the questions that would come up with sensitive populations that we don't often talk about is the fact that this sensitive population may be an allergic population or a population who has sensitivity to the food itself. Those give us special concerns when we're dealing with allergens. And then the next thing that we do to inform our hazard analysis and give it structure is to produce a process flow diagram. And usually this is just a little flow chart. It goes, normally this is not as complicated as an engineering diagram, but it gives us steps in the process. And during those steps in the process, what we need to do is we need to annotate it with inputs and rework and materials such as introduction of air, water, gases, and process conditions, including temperature and time. The process flow diagram often doesn't have the temperature and time associated with something, for one thing. I have worked with one company who had a process flow diagram. They had a hazard analysis and everything. But when I walked in, I found that there was a cook step that was holding the product for a long period of time. That was not on the process flow diagram. If you're holding the product for an extended period of time, you need to know about that. And you may want to be considerate of potential growth of pathogens, Clostridium perfringens, for instance, or staph. And then after you get the process flow diagram all set up and annotated with all these inputs, somebody needs to take that flow diagram and make sure that's really what's happening on the floor. Because if you don't verify the flow diagram, chances are good something's going to be missed. The verified flow diagram itself provides structure to the hazard analysis. And now, so how do you go about structuring the hazard analysis? It's common to conduct a hazard analysis on ingredients separately in a table. If you've got a whole bunch of different types of ingredients or even packaging material, this works pretty well with. Go ahead and put those in a table and go through all the different types of hazards and make yourself a table of all ingredients, all packaging materials, and conduct a hazard analysis right there. What are the special hazards that might be associated with that? Most people do that just to get it off to the side. That way you don't have to do this hazard analysis on ingredients directly in the process flow diagram. Okay, but the traditional way of organizing the hazard analysis on the hazard analysis worksheet is to list the steps in the flow diagram. That verified flow diagram, list the steps there. And normally when I teach hazard analysis, I recommend that each step in the process be described and the conditions associated be noted on the hazard analysis worksheet. I'll show you a hazard analysis worksheet at the end of this presentation. But essentially what I like to do is to the left of each step in the process, I like to describe what's happening at that step so that someone who has taken a look at the hazard analysis worksheet understands just what we're dealing with. Okay, then how do you get started? Well, you get all these folks together that are on your HACCP team and get somebody to start keeping records of what's going on. You should identify the potential hazards at each step of the flow diagram. Normally I like to do that as a brainstorming session. Make sure you've got appropriate guidance resources. Make sure there's someone who is knowledgeable of a product and the process. Make sure there's someone who is knowledgeable about food safety hazards. And if there exists a good hazard analysis guide, use it. In this first step, where we're identifying the potential hazards of each step, you should avoid the urge to evaluate the hazards. Just get those down on paper. And in that situation, along with getting them down on the paper, we'd like to identify the hazard and its occurrence both. And I'll talk to you about the occurrence of the hazard on a couple of slides down the line. And remember, identify hazards, not conditions. Temperature is a condition. A hazard would be the growth of pathogens. So be specific about that. Let's just take a look at this little diagram here. And this is the reason that we're interested in dealing with documenting the occurrence. We have three columns here: the process step, the potential hazard with the occurrence, and the preventive controls. Well, let's just take broccoli, for instance. This may not be a particularly good example for your operation, but let's just take a look at receiving broccoli head. Let's do a brainstorming. Let's do a brainstorming session and think about what is a potential hazard and how would it occur. Well, actually, when we receive broccoli heads from the field, we could assume that there are going to be pathogens that come from the soil, come from the environment, and they're going to be present on the broccoli. Okay, now there's not much way you're going to be able to remove those pathogens from the broccoli. So the preventive control that you're going to have to work on later on is going to have to be the destruction. So that's a very special preventive control, and that happens to be one of those preventive controls that has to be dealt with in the process itself. Can we have other types of preventive controls? Yeah, well, let's take a look. If we're washing and trimming the broccoli, what's it exposed to? Well, in addition to the fact that we have the presence of pathogens from the field, what we're going to have is contamination and potential growth of the pathogen in that product. And that could come from the water, it could come from personnel. So we've got our water program that includes rechlorination and water quality and that sort of thing. We've also got our personnel problems associated with handling anything. Anytime you have something being handled by personnel, you have the idea of personal hygiene. Now, the preventive controls for dealing with contamination from the water program, or from the water and from personnel, are dealt with by other controls. Those are dealt with things like our sanitation program and our personal hygiene program from the sanitation program. Those are separate things from this preventive control that we have to deal with in the process itself. And then there's the whole concept about cooking and cooling broccoli. If we, again, I did a little bit too hard. Cooking and cooling broccoli, one of the concerns we have is, what about recontamination from the equipment, from the environment? Well, our sanitation program is going to deal with that. Now, by the time we've got to the cooking and cooling, we've probably been able to destroy the presence of the pathogens in the field. So now what we've got is we've got a product that has very little microbiological competition associated with it, and there's a good opportunity that we're going to end up with a problem with recontamination. So that sanitation program becomes extremely important in this particular situation. Also, if we're using the cooling by using water, then we've got to worry about the cooling of the broccoli with the water that might be contaminated. So our recontamination program might come back into concern there. Well, what are some of the resources that are necessary for conducting the hazard analysis? If we do this, um, we need some resources that we can depend on. Unless, you know, I'm a, I've got about 40 years experience in this business. Do I want to use only my experience in conducting the hazard analysis? Probably not. So you're probably going to want some expertise from someplace else. So take a look at, do you have enough experience with the product or similar products or processes? Are there people from your plant? Do you need third-party assistance? Where are you going to get these resources? What about scientific reports, illness data, and predictive models? Those are all available on the web, and you can go searching for that. If you've got somebody who knows what to look for, you can come up with a whole lot of information here about the kind of things you might need to look at for conducting the hazard analysis. Since I'm working now as a consultant, but I spent a lot of time as an extension specialist, I'm pretty partial to expert advice from third parties. And I'm also very partial to established regulatory controls. What kind of regulatory controls were used in the past? And did we actually have enough help from those regulatory controls that we could go ahead and introduce those controls right now? Trade organizations, many trade organizations produce hazard guides. Take a look at those. And textbooks, don't forget about the books that have been written about it. Okay, so who conducts the hazard analysis? Well, the hazard analysis is part of the food safety plan. And according to regulation of 21 CFR 117, the food safety plan must be prepared or its preparation overseen by one or more preventive controls qualified individuals. You've probably heard about the PCQI ad nauseam, especially if you have in the past taken a PCQI course. But the preventive control qualified individual is the person who has learned the requirements of the regulation. Now, that doesn't mean that they're an expert on the food safety aspects of everything. It just means that they know how to follow the regulation. So you need not only a PCQI who has been to the course, but you need to have someone on the team who has expert knowledge. So what do you consider? The regulation says that you need to consider a lot of things. Consider these things on the safety of the finished food. First off, the formulation of the food. Is there some aspect of the formulation that could be changed to make the food safer, or is there some aspect of the formulation that causes the food to be potentially unsafe? Consider your equipment and your facility. Does the condition or the function and design of your facility and equipment contribute to contamination? What about storage? Where do you store things? Are you storing raw materials and other ingredients where they might get contaminated? And what about the raw materials and other ingredients themselves? Are they inspected properly as they come into the process? Have you got specifications set up, and are you following those specifications? And is someone actually performing an inspection? Is that a knowledgeable someone who determines the materials and the ingredients? And somebody just take a look at ingredients that are coming in that might have a change. Let's say you've got a compounded ingredient. Is there a change on the label? Are you taking a look at that? Transportation practices. Is the product transported in a refrigerated trailer? Is it frozen? Is it supposed to be frozen? Is it clean? What's going on there? Manufacturing procedures. What are you doing in manufacturing that might improve the process itself? Or what are you doing in manufacturing that might contribute a hazard to the process? What about packaging activities and labeling activities? Is there a chance of getting these things mixed up where they don't really work as they should? And then storage and distribution. How are you storing it? How is it going to be stored? How are you going to warehouse it before shipping? And what about this distributing? What about intended or reasonable foreseeable use? How is somebody going to use the product? We think about the concept in the past where, well, when I was growing up, my mother used to leave us out some frozen chicken pot pies for when we came home from school. And when we had those frozen chicken pot pies out there, we normally stuck them in an oven and cooked them. And we had, we cooked them until they had the right temperature and we were fine. Cooked them the right amount of time. But something changed in there. A generation came along that didn't use the oven very much. They used a microwave. Did that change things? Is there an unintended way of using the product from the standpoint of the consumer? What changed? Take a look at that. What about sanitation, including things like employee hygiene? What other relevant factors are there, such as weather-related nature of some hazards? For instance, aflatoxin. Could aflatoxin be increasing due to the weather-related hazards we've had? And what do you know about the weather-related hazards in the area where your product is coming from, where your raw materials are coming from? Is it possible that there's something there that's contributing that you don't know about? And then when it comes to identifying the potential hazards, remember the definition for hazards itself. The definition is that a hazard is something that's likely to cause illness or injury in a consumer. So deal with the hazard, not quality or regulatory items. Concentrate on safety. Identify the hazards, not conditions. Remember, we said that the growth of a pathogen is a hazard. The conditions may or may not give you enough information. Just because the temperature is high or low, that doesn't necessarily tell you what the hazard is going to be. So temperature is a condition, growth of a pathogen is a potential hazard. Be specific to the occurrence of the hazard. What is it that causes the hazard to occur? Because if you can be specific to the occurrence of the hazard, then you might be able to eliminate the hazard or control the hazard at a lesser level using a different technique. So think about the hazard's presence on incoming raw materials. What about contamination or cross-contact during the process? What about growth or concentration in the process? What about toxin production? So, evaluate the potential hazards by classifying the potential hazards according to their occurrence, the method of management, and then the method of management or control might become obvious. Take a look here. We have the occurrence of a potential hazard is the presence on an incoming raw material. Well, what do we have to do there? Usually we can't get rid of those kind of hazards. If they're microbiological, for instance, we usually have to have a thermal process. So we have to have a process control in place in the hazard when we control the hazard. What about contamination from the process? Well, if there's a contamination from the process, can we deal with that with sanitation controls rather than having to have another thermal process in place? What about growth or toxin production? Can we control the temperature so that there is no growth, and that since there is no growth, there will be no toxin production? And what about allergen cross-contact? What kind of controls would we do there? Well, we might have two different types of controls. We might have sanitation control, and we might have an allergen control just as a check. Some potential hazards are not likely to occur as a result of properly implemented preventive control. But if we decide that they're not likely to occur, we still need to go ahead and have an identified management control there. And that control usually has to be, I usually say, checked, implemented, checked, corrected, and documented. Okay, so what is a hazard that requires a preventive control? A hazard that requires a preventive control is a known or reasonably foreseeable hazard for which a person who's knowledgeable about the process would, based on the outcome of the hazard analysis, establish one or more preventive controls to significantly minimize or prevent the hazard in a food or components, and to manage those controls as appropriate to the food, the facility, and the nature of the preventive control and its role in the food safety system. Now that's a mouthful, but essentially it means if you have a knowledgeable person who thinks that there's a problem, you've got to establish a control. Okay, and then how do you document all this hazard analysis stuff anyway? Well, maintain the minutes of the HACCP team meetings and the decisions you make. Keep a notebook. Make sure everything is logged. Any sources of technical information you use to make decisions, make sure you log those things. And then summarize them on the hazard analysis worksheet. Here is an example of a hazard analysis worksheet that has been used in the past. Now we would modify it just slightly to deal with preventive controls, but let's take a look at some of the components. If you take a look at column 1, where it's talking about the ingredient or processing step, if the processing step is pumping, for instance, there's a description there about what's happening at that particular step. Milk is conveyed to the filler under pressure using sterile air. Okay, what are the potential food safety hazards there? Recontamination of sterilized milk with pathogens could be a problem, or spoilage microorganisms that might cause gas formation or loss of package integrity might take place. How do we deal with that? Well, the control measure or the preventive measure is the air sterilization protocol that we use. What about packaging material preparation? Well, at that step, roll stock packaging material is conveyed to the hydrogen peroxide bath, and hydrogen peroxide is evaporated by heat. This is part of the protocol of the packaging machinery. So, what's the potential hazard? The potential hazard right there is recontamination of sterile milk by non-sterile packaging. Are there any other potential hazards? Well, yeah, we just put H2O2 residues on the packaging material. Are they likely to get into the food? Well, we have to evaluate that. First off, the biological hazard, well, you know, that could happen if we don't do it right. But in terms of the chemical hazard, we've got a justification here that says that's not likely to occur because the chemical residues of more than 5 parts per million are not allowed by the regulation. This is a regulatory limit and is not directly related to safety in this particular product. And so what sort of control measures might we put in place, or preventive measures, or preventive controls? There's the sterilization of the aseptic filler itself, and there's the maintenance of hydrogen peroxide. And then filling and closing, similar. Milk is packaged in an aseptic form-fill seal machine in a properly designed and maintained aseptic zone. We have potential biological contamination, but we say we're going to take care of those because we have an aseptic filler protocol in place that's going to deal with it. So generally, that's how our hazard analysis worksheet might be set up. I want to make sure that I repeat that that the recording and slides for this presentation will be available on the Perry Johnson website, and that if you would like to ask any questions, you can actually go to that website and ask them. I want to thank Amy Wayne for supervising the technical aspects of this presentation. It's my first time with a webinar. As you might have figured out, it's kind of unusual to talk to a computer instead of to people. I'd also like to thank Ram Narasimhan for inviting me to give this presentation. I see that there are no questions that have been listed under the list of questions. I'll wait for a minute before I sign off, but if anybody has any questions, please. Oh, there is one. Here's testing. Isn't it required to identify the microbiological or biological hazards by name during the hazard analysis? That's a good question. I think that, Jennifer, the requirement is that you deal with the hazard directly. It doesn't say that you've got to name it by name. However, I have always taught that if you identify the hazard by name in the early going, you can get to the control measure a lot faster. So yes, I would recommend that. It's not a requirement under the regulation, but I would recommend that you do that you actually identify it by name. And E. coli, maybe not. Vegetative pathogens might cover E. coli, depending on what you're dealing with. So it depends on the control measure. If it informs your decision as to what control measure to use, yes, identify it by name. Any other questions? All right. Well, I'm going to go ahead and sign off then. Thank you very much for the time. Thanks again to Ram and to PJRFSI and to Amy Wayne for helping us out. Remember that the recording and slides are available on the PJRFSI website, and they should be available in 24 to 48 hours according to what Amy tells us. Thank you. Bye.